All right, so we're going to go through the spell work real quick, and then it's going to feel like a big old change in concept today. It's not. It's very much related, but it's going to feel like it. So our first thing we're going to look at is what are the other three words that mean solutions? X-intercept. X-intercept, root, and zero. Those all mean the same thing. Solutions, x-intercepts, roots, zeros. They are used interchangeably. You will see all of them in questions that are asked. So it's really, really important that we remember those words all mean the same thing. Speaking of our roots, solutions, x-intercepts, and zeros, on this picture, we're just asked to find them. Where are they? 2, 0, and negative 4, 0. Absolutely. They're right there. It's where it crosses the x-axis. And then here's the thing that feels way out of left field. We're going to look at some square roots for a second. What is the square root of 16? 4. That one's not too bad. How about the square root of 50? Ooh, screen. Let's not be a jerk. How do we do this? It depends on where you learned it as to how you do it. Some of us do the birthday cake, where we're dividing out prime numbers to 25, 5, 5, 1, if that's familiar. It could be that you divide 50 up inside the radical, where we make it 2 times 25, because that's a perfect square. You could make a factor tree. There's lots of different ways to do it, but what we're really doing is we're looking for perfect squares, meaning pairs on birthday cake, or a perfect square that I can pull out of my radical. So I take the square root of 25, it's 5, right? And then left over, I have the 2. Same thing, that 2 is still left over. So either way, we're going to get 5 square root of 2 as the square root of 50. We're not going to be putting these into decimal form, but we are going to be simplifying radicals, which is something you have seen before, but it may have been a minute. How are we feeling about the radicals? Vaguely familiar, I hope? Because we're using them a bunch today. Bunches and bunches and bunches. Because we're going to be working with a very bizarre concept today. Because remember those graphs we'd have where they wouldn't touch the x-axis at all and we'd have like no x-intercepts, no roots, no solutions? That irked mathematicians real hard. It bothered them that they could not get all the way down to a solution. So they made up a way to do it. They invented something to help them find a solution when there's not a real solution. So what we're going to be working with is we're going to be working with imaginary numbers. Imaginary numbers use the term I. That's a J. I went the wrong direction. So I usually put a little hook on my eye so it doesn't look like a 1. And what I is the square root of negative 1. Because when we are working with square roots and we are pulling things out, we can't do negative numbers. There's nothing that 1 squared gives me a negative, except for I. So we're going to treat these square roots here just like we did the 50. I'm going to flip back for a second. I promise I'll come back. I'm going to work things this way today if you like the birthday cake, this still totally works. But I'm going to go this way with our square roots, with the factoring inside the radical today. So I'm going to start with the 75 because I feel like that's a little easier to see what's going on here. And what I'm going to do is I'm going to break this up into terms that are being multiplied. So I want that -1 separate from everything. And then we're going to take 75 and we're going to break it up into pieces. I can see right now 75, I could make that out of quarters, so 75 cents. I could make with 3 quarters that are 25 cents a piece, right? Or we can notice that 25 is in fact a divisor of 75. The reason that helps is with radicals, I can cut it up into pieces. -1 times square root of 3 times the square root of 25. 2 of these pieces we have further information for. The square root of 25 is what? 5. Up at the top of the page, we just said that the square root of -1 we call I. So we're left with only one piece inside the radical. That's the 3. So the simplified form of the square root of -75 is 5I square root of 3. I'm not super picky about the order. It's just easiest to read if we put all the things outside the radical in front of it. But if you said 5 square root of 3I, that is okay. These are a lot and these are a little weird. So let me know what you're thinking. Because we're going to do the same thing with the 294. We're going to take our calculators because we can utilize tools. And we're going to see what numbers divide into 294. Okay. So I can see that 294 is definitely even. So I know the -1's going to come out. I can see that 2 is going to come out. 194 divided by 2 gives me 147. Well, it's not even, so I'm not taking another 2. We can divide 147 by 3. And that gets me 49. So we're going to divide by prime numbers until we get somewhere that has a perfect square. Because I like 49. 49 is a good friend. We love it. Because again, I can break these up. Square root of -1 times square root of 2 times square root of 3 times square root of 49. Square root of 49 is 7. Square root of -1 is the piece we call I. And then these two chunks don't have any buddies. You can't come outside in radical land unless you got a buddy. So we're going to take them and we're going to keep them under the radical. And we're just going to have 2 times 3. So just like we broke them apart, we're going to put them right back together. So this becomes 7I square root of 6. they're a little weird to get used to. Like, it's one of those things that it just takes practice to get used to. We're going to practice it a couple more times. But then we're going to start doing some kind of crazy things to it. Because sometimes they'll tell you to multiply them. What we're going to do is we're going to come in and we are going to simplify each one first. So I'm going to make this 10 be -1 times 2 times 5. And I'm going to write my square root of -15 is -1 times 3 times 5. Which means I could break these up, and if it helps you to break up every single one, we can absolutely do that. Square root of 5, square root of -1, square root of 3, square root of 5. This guy is called I, and this guy is called I. I have 2 square roots of 5. If I put those back together, we get square root of 25, which means those actually just equal 5. And then we've got 2 loner guys left inside the radical. So we're going to have square root of 2 times 3. And I've got 2 i's, which means it's going to be I times I, which is I squared. We're not done yet. I'm going to rearrange because this guy's gross. So we have 5. Square root of 2 times 3 is 6. And then I want us to think for a second on I squared. What that really is, that's square root of -1 squared. What happens when I square a square root? They cancel. So I squared is -1. So when I have I squared down here, and I need another color. Let's go with orange. I squared down here means -1. So thank you, sir. -5 square root of 6. We're just going to cut things up into pieces. Break it up into as many pieces as we need. Then we're trying to find some pairs. We're always going to try and simplify first. Let's look at the right-hand one. I can take my -16 and split this out to be -1 times 16. 16 is a perfect square. We love that. Square root 25 I can do as -1 times 25. Again, we love a perfect square moment. Because if I split these up into individual pieces, we can see a bit of what's happening here. The square root of 16 is 4. The square root of 25 is 5. We said before, the square root of -1, that's I. And the square root of -1 is I. These pieces are all still being multiplied together. So we have I times 4 times I times 5. Well, 4 times 5, that's 20. Then we're left with I squared. We just looked at I squared at the top. I squared, that's the square root of negative 1 squared. That's just negative 1. So we get negative 20 as our answer. Eyes are weird, and they are tricky to wrap your brain around. Once we get the hang of them, they're not too awful. But they're weird because they're literally made up. That's why they're called imaginary. Mathematicians made them up to solve a problem they couldn't finish. Because mathematicians be extra. They're weird. And I get that, and I'm sorry. It's one of those things we have to do, though. Because what we're going to look at next is why the heck we need them and why the heck are we talking about them now? Because what we're about to start doing is we're about to start solving quadratics algebraically. So not by graphing it. We're not graphing these guys. No arts and crafts today. So this is going to be solving with square roots. So what we're going to do is if I have x squared, no x's, and a number, I'm going to put them on opposite sides of the equal sign from each other. I want x squared equals. So for this one, what we're going to do is we're going to subtract 81. That's going to give me x squared equals negative 81. All right? I want to know what x is, not what x squared is. So to get x by itself, I need to undo that square. To undo the square, we use the square root. Whatever I do to one side, I do to the other. That's going to make my squares cancel out. And we get that x equals, and then when we are solving like this, and we had x squared, and we're undoing that, we have to remember that we don't know if the number that was being squared was positive or if the number that was being squared was negative. Maybe it was negative. Maybe it was positive. So we put plus or minus. We have that square root of negative 81. But we don't like having negatives and radicals. So we're going to simplify the negative 81. So x equals plus or minus, and I'm going to take this square root of negative 81, and we're going to do just like we did before, negative 1 times 81. Well, the square root of 81 is 9. And the square root of negative 1 is I. So I'm going to erase this set right there. So what we get for our solution is x equals plus or minus 9i. Literally, mathematicians invented these so they didn't have to leave their answer like this. This bothered them enough to come up with this idea. They made up these imaginary numbers so they could finish solving this and getting it out of the radical. That is why. Because mathematicians be crazy. Okay, the one on the right-hand side is the same kind of way, but I need to get my x squared by itself first. So to get my x squared by itself, what we're going to do is we are going to subtract the 27 from both sides. We're going to have 3x squared equals negative 27. If I square root right now, am I going to wind up with something tidy? Is the square root of 3 something friendly? Or is the square root of 3 gross? It's gross. We don't know what square root of 3 is. We don't want to deal with that. So let's move him to the other side too. So let's divide both sides by 3 and not have to deal with square root of 3 being over here with my x friend. So we have x squared equals negative 27 divided by 3 is negative 9. Oh, we love that. 9 is much better than 27. Because when I come through and square root both sides, my square root and my square cancel out. X equals plus or minus square root of negative 1 times 9, which means that x is plus or minus square root of 9 is 3. Square root of negative 1 is I. So again, these are weird. These are our solutions. Put it on this one too. But they're weird, and I know they're weird, and I'm sorry. But it's one of those things. We will need them when we get back from fall break. We'll be working with like the quadratic formula kind of stuff, and we need to have I and be familiar with I when we're doing those kinds of things. Okay, so I's gonna come back lots of times. So I know it feels like it just like kind of comes out of left field, and it feels awkward and it feels weird. We are going to work more with I on Monday. But it's one of those things that it just takes practice. It just takes practice. Okay. So I'm actually going to give you guys the last 12 minutes, more than, almost 15 minutes, to work on homework and things. I do have the homework over imaginary numbers here. I know I just gave you one yesterday. This is the last paper homework before fall break. Everything next week is going to be on Alex or on like the review. I'll get you a paper copy. Thank you, sir. But so this is the last paper like homework until fall break. Okay, so this is homework 3.3. I'm going to give it to you. If you wind up needing another copy on Monday, that's fine. I got you. But I want you to have it. The front page is what we did today. The back page is what, the back side of it is going to be what we do on Monday. Okay, so practice these things. Practice, 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 practice. And I know these are weird, and I'm sorry, they're awkward and weird. What's up? Air quotes. If it doesn't get until Monday, that's totally fine. Okay. Yeah. That's what we're gonna do on Monday. Oh, you just have single sides. There we go. Train me. I'll take this one. Here, give me the one that only had one side. There you go. Not that. Okay, so you guys have the